In Chapter 10, we are graphing quadratic functions, which are going to make a parabolic shape on our graph, a U-shaped graph, and we are going to walk through how to do that algebraically. So we have y equals x squared plus 6x plus 8, and the first thing we're going to do is factor it out. So we are going to set up our diamond and our rectangle, which we did in Chapter 8, and we need two numbers that multiply to give us 8x squared, but add to give us 6x. Oops. So 4x and 2x would work, and once we plug them in, we can find the dimensions of a rectangle. So we'll have x plus 4 times x plus 2. These are our factors. We're going to set these equal to 0. So we are going to take x plus 4 equals 0, and x plus 2 equals 0, and we will solve for x. So x is equal to negative 4. So one of our x-intercepts is negative 4 comma 0, which I'm going to plot on my graph. The other factor, we're going to subtract 2 from both sides, so x is equal to negative 2. So the other x-intercept is negative 2, 0. So we're going to plot those 2 points on our graph. So next thing we want to do is we want to find the y-intercept. So we are going to plug in 0 for every x that we have, and that's going to just turn out to be y equals 8. So our y-intercept is 0 comma 8. So we can plot that point on our graph. And then the last thing we want to do is find our vertex. So for the vertex, we want to find that lowest or highest point of the parabola. In this case, it's the lowest point, and it needs to be on that line of symmetry. So we are going to take the x-intercept points, so we're going to take this negative 4 and negative 2, and we're going to add them together. So negative 4 plus negative 2, and then we're going to divide them by 2. So we're going to take their average, so negative 6 divided by 2 is equal to negative 3. This is the x value of our vertex. And if you look at the graph, in between our two x-intercept points is negative 3. So I'm just going to draw a dashed line there. That's going to represent that line of symmetry. So if you need a visual, so if we were to cut that parabola in half, on that dotted line, the left and the side would match up equally. So we know that the x value is negative 3 for the vertex, but now we have to find the y value. And what you're going to do is you're going to take that negative 3 and you're going to plug it back into x in the original problem. So I've slowly run out of room here. So I'm going to do this up top. So you're going to take y equals negative 3 in parentheses squared plus 6 times negative 3 plus 8. Which then in turn is going to give you a negative 1. So our vertex is negative 3, negative 1, and we can go down there and plot the point, and then we can connect our points and have our concave up parabola. In this second example, we have y equals x squared minus 3x plus 2, and we're going to start by finding the x-intercepts by factoring it out. So we're going to set up the rectangle and the diamond. So we need two numbers that multiply to give us 2x squared, but add to give us negative 3x. So that's going to be a negative 2x and negative 1x. Plug them back in, and we're going to find our factors, our dimensions of a rectangle. So we have x minus 2 and x minus 1. We're going to set them equal to 0, and we're going to solve. So x minus 2 equals 0. If we add 2 to both sides, x is going to equal 2. So one of our x-intercepts point is 2, 0. Just going to make a note here, 2 comma 0. The other one, x minus 1 equals 0. We're going to add 1 to both sides, so x is going to equal 1. So we'll have 1 comma 0. So the next thing we want to do is find our y-intercept. So we're going to plug 0 back in for x. So y equals 0 squared minus 3 times 0 plus 2 So y is going to equal 2. So on our y-intercept, we'll have a point at 0, 2. And this is going to be a concave up parabola. It's positive. It's going to be opening upwards. And now we want to find the vertex. So remember, the vertex is an ordered pair. So we are going to start by finding that line of symmetry. So we are going to take the x-intercepts and find their average. So we're going to do 2 plus 1 divided by 2, which is 3 over 2, which you could write as 1.5 if you'd like. So we have 1.5 as our x value, and if you look at the graph, I'm going to draw that little dotted line there to represent the line of symmetry at 1.5. So at that 1.5 line of symmetry, that is where the left and the right side of the parabola are going to match up perfectly. So to find the y value of this vertex, because remember we need an x and a y, we're going to take 1.5 and we're going to plug it in for x in the original equation. So we're going to have y equals 1.5 squared minus 3 times 1.5 plus 2. When calculated, it will give us negative 0.25, or negative quarter. So on our graph, we will go down just a little bit, and we'll have our point. And then we can connect them, and we have our parabola.